All right, hello everyone. Welcome, welcome. Let's go ahead and get class started for today. I hope you all had a great weekend. Actually, I want to start out today talking about something that's coming up a little bit later on this week, which is assignment 1. It's your first homework assignment that's due for credit. I know we had assignment 0 due last week, and I hope that you took a look at that and or submitted it just to kind of get used to how that process works. But since this is the first one that actually counts towards your final grade, I wanted to spend a few minutes at the beginning of class just talking about exactly what that means and make sure that everybody's prepared for when they come to class on Wednesday to submit the assignment. So what I really want to make sure that you're aware of is actually nothing to do with the assignment itself, but actually down after this. So if you scroll on Canvas, if you scroll past all of the instructions, you'll see that there's a rubric posted for the assignment. And this is true for all assignments. Every single homework assignment you get in this class is going to have a rubric posted for it on Canvas. And this is quite literally what the TAs are going to ask you when you show up to class on Wednesday, or if you go to office hours to turn in instead. Whenever you turn the assignment in, the TAs are quite literally going to stop at the top of this list or start at the top of this list and work their way down to the bottom, asking you all these questions one at a time. So, these first 5 points are kind of freebies. You get that just for signing up on the lists. And like we saw in class last Wednesday, they'll ask you to run the program and then give you points based on how well it works. And then here's really what I want to make sure everybody understands. While you do get some credit just for having code that works, what we really care about is not so much whether your code works or not, but how well you understand it, right? So yes, code working does matter, but what matters more to us is that you understand how your code works. So a lot of what you're going to see on the rubrics are questions like this. The student can explain what data type was chosen and why, right? The TA is going to literally ask you that question. What data type did you choose for the number of studios, and why did you choose it? And you're going to be expected to answer that question on the spot, right there on the spot when you turn it in. But it shouldn't be a surprise, right? You know they're going to ask you that question. You should prepare the answer to that question ahead of time and be ready when they ask you that question. You should have that answer ready to go. That's the expectation. The expectation is you're aware of this rubric. These should not be surprises. You should be prepared to answer these questions when you come to turn your homework assignment in. Some of them are going to ask you to identify lines. So identify a line where scanner is used to read in a double. Could happen multiple places. I don't care which place. Just I need you to show me one. Again, that's something that you should know ahead of time, right? And if you worked on the assignment, it should hopefully be fairly easy, fairly simple, fairly straightforward for you to point out. And so much of the rubric is actually going to be based on these kinds of questions. And I want to point out that, again, we expect you to prepare for these things ahead of time. You should not be trying to figure out the answers to these questions during the demo process. So if you don't know the answer and you're sitting there scrambling trying to figure it out, my TAs have been trained to be like, sorry, you should know the answer. If you don't know the answer, that's a 0, right? They're not going to give you 5 minutes to look up the answer right there on the spot. That's not the point. The point is you should know this. By the time you get here, by the time you finish the code and are ready to submit the assignment, you should know this stuff. It shouldn't have to be stuff that you need to look up on the spot. Similarly, I know somebody asked actually a question about this on Piazza not too long ago. I thought it was a fantastic question. A lot of people like to put comments in their code. I don't actually have a problem with that. I think actually it can be easy to overdo it with the comments. I think you maybe oftentimes don't need as many written notes in your code as perhaps you think you do. But I want to reiterate that we're not asking your notes these questions, right? We're asking you these questions. So if your response to this question is to look down at the answer that you wrote on a sheet of paper or the answer that you wrote in your code, the TAs are also trained to be like, hey, I know you know how to read. You wouldn't be at WashU if you didn't know how to read, right? I want to know if you know how computer science works. So reading your answer does not convince us that you understand what's going on. It just shows us that you know how to read. That's not an impressive thing at this point in time, right? Not to us anyway. So while writing those answers out might be a useful way for you to prepare, right? Please do not show up with the whole script written out on a sheet of paper and just read it back to us. That's also not going to end well for you during the demo. I actually think that you should think of these as oral quizzes, right? You're being asked questions and answering questions and graded on the actual words that come out of your mouth in that moment in time, right? Not what you've written down, not what code you've written, but the words that are coming out of your mouth. And I definitely am fully aware that, ChatGPT can answer all of these questions very simply. ChatGPT can put comments in your code to explain what every single line of code does, right? Definitely not going to be giving out points for stuff like that. That's not a good use of ChatGPT. That is a very poor use of ChatGPT. Using ChatGPT in that way, in my opinion, shortcuts the learning process entirely, right? I know ChatGPT is good at stuff. I want to know that you're good at stuff. I want to know that you know this stuff. I want to know that this stuff is in your brain. Not that it's on the computer, but it's in your brain. That's what we're looking for these demos. So please take a look at the rubrics ahead of time and prep yourself, right? Get to know what's going to be expected of you. Make sure you know what the answers are and be ready to talk about them. Don't just write them down, but be ready to talk about them. It's a very, very, very important part of this class and of turning in the assignments. Are there any questions about the rubrics that I can address, or what's going to be expected of you on Wednesday? The other thing that I want to point out about turning in assignments on Wednesday, you'll notice that the due date for these is set to be about half an hour after classes started. So if you're in the 1 o'clock section, the quote due date on Canvas is at 1:30. That does not mean that you can roll in at 1:29 and expect to get your assignment demoed, right? That half an hour is our time to get through all of the people who want to submit the assignment that day. That is the very tail end. In fact, I'm hoping we can finish it in faster than half an hour. Just like you saw in class last week. When you come, you're going to sign up on the lists, and the TAs will call out your names and go around the class and demo the assignments that way. Once all the demos are done, once the lists are empty, the lists get closed, we don't accept any more after that. We're moving on to the studio as soon as that's finished. So what that means is that if we go around the labs and we get everybody finished in 10 minutes, we're turning the lists off. And if you roll in 15 minutes late, I'm sorry, it was due at the beginning of class. You need to be there at 1 o'clock or whatever the beginning of your class was and sign up for the list at that point in time. Just because this is the time that says on Canvas, this is our buffer, right? That does not mean you can roll in to class at 1:29 and expect to turn in your assignment. That is not going to work. You got to be there on time, get on the lists, and as soon as the lists are empty, as soon as we've demoed everybody, then we're done. We are not accepting any more after that point. The TAs have been trained to not accept any more assignments once the lists have been turned off. So please don't, please come to class on time, I guess, is the big moral of that story, and be ready to show off your work. Although, as I've mentioned in prior classes, if you need some extra time, you can take that. You have late coupons available to you. Actually, I haven't distributed them yet, but I will. It's because now we actually have the option to use them. If you want to use them, you don't need to ask permission. You can just submit the assignment on Thursday or Friday, and it'll just automatically work. I have office hours on Thursdays and Fridays if you want to take advantage of that. So just want to make sure everybody knows exactly what's coming up. I'm going to give you one more chance to ask questions about the homework assignment before I hop into what I'm hoping to do today. Does anybody have questions about assignment 1, how to turn it in, what's going on in the labs this week, anything like that before we take a look at today's topic? Yes?
Can we turn in assignment 1 or assignment 2 this week?
Assignment 1 is due this week. Yes, assignment 1 is due this week. And it will follow that process. It'll be usually one assignment due per week unless we have an exam. That kind of throws the schedule off a little bit. Okay. Any other questions before I switch into this? Okay, so let's talk about what we're going to do today, and actually what we're going to be doing every Monday. So again, the expectation was that you have looked at the Module 2 exercises before coming to class today, right? That is what I am expecting to be true. I realize that may not be true for everybody, and I think it's the beginning of the semester. That's probably okay for now. But I do want you to get into the habit of at least looking at this material before coming to class, because what we're going to do here in class is more practice. More practice. So I've actually made a repository for you all called Module 2 Review Problems. This is just like you saw in the studio and the assignments. It's going to do one of these things again, where you have to accept it and then import it into Eclipse. You're going to get used to that. You're going to do that dozens of times this semester, right? You're going to do that a lot. So here's another example of loading up some exercises. These are going to be done in class. These are just for the purposes of getting some additional practice in class today. And the way that it's usually going to work is I'm going to start class by just asking some general review questions from the materials. After that's done, I'll give you the opportunity, if you have any questions or if you want to see me walk through one of the examples from the exercises, or even more than one, right? I'll go through any of the exercises you want me to. If there was one you got stuck on, or you just don't understand, or you just want to hear somebody talk about it in more detail, that's what we can do. And then once that's done, I've prepared some additional exercises that we're going to work on here in class. I'm going to give you a chance to work on them with your neighbors, and then I'll walk through the solutions together as a group. And the idea is to just get you as much practice as humanly possible. That is the best way to learn how to code, and so that's what I'm going to try to do. Just give you as many opportunities to practice and talk about these concepts as humanly possible. So, with that in mind, I've actually already got this loaded up into Eclipse. I would encourage you to load this up into Eclipse as well, and I'm going to start with the first one. That's just called Review Questions, and you can see I've just got some simple questions written out here in English, and I'm going to answer them in English, or actually I'm going to ask you to answer them in English. Starting with the first one. What is a relational operator? Or, can somebody give me an example of a relational operator? I would accept that. What's an example of a relational operator? Who can help me out? Somebody in here has got to know. I hope. Yes?
They compare numerical values or arithmetic expressions.
Yeah, so the answer was that they compare numerical values. Another word or another term for relational operator is a comparison operator. You might actually hear them called comparison operators. I know that you've used some of these. You would have had to have used them, in the studio last week, for starters. What's an example of a comparison operator? There's at least half a dozen or so. So we're comparing two values. I want to see if a value is perhaps greater than or less than. Those are comparisons, right? What other kinds of comparisons do we have? Yeah. Equals. So how do I say that? Yeah, good. We need a double equal sign to say equals to. Why don't we use a single equal sign?
That's assigning.
That's variable assignment. Good, yeah. When the computer sees just one equal sign by itself, it thinks, oh, you're making a variable. You're putting a value into a variable. That's not the same thing as what we're talking about, which is asking the question, are these two things the same? So in order to ask that question, we use double equals. That's how we compare things to see if they're the same. What about the opposite? How do we say the opposite of that? I know not equal to, but how do we say it on the computer? Exclamation point equal to would be not equal to. So if values are not equal to each other, we would use exclamation point equal to. And actually, we can combine equals with the other ones as well. So I would read, that as less than or equal to, greater than or equal to. Right? These are relational operators. These are comparison operators. I'm comparing two values to see if they're the same or greater than or less than or whatever the case may be. What do I get back from these relational operators? I say, 2 is less than 7, and the answer it says is it'll say true, which is I heard somebody else say that's a Boolean, right? It's a Boolean. So for every comparison that I make, for every one of these relational operators that I use, it's going to give me back either true or false. It's going to give me a Boolean every time. Every single time, it's going to give me back a Boolean, true or false, which is going to be important for us as we kind of progress and talk about some more stuff later on today. Let's switch it up a little bit and go to this next question. What's a logical operator? So we just talked about relational operators. What are logical operators? Somebody give me an example of a logical operator. Yeah, in the back. Yeah, great. And is a logical operator, and there was a sort of a complementary one. Or, what's this? That's what this one is. So double ampersand for and. What's this symbol called? Anybody remember? Starts with a P. That one's called a pipe. It's above the enter key on your keyboard usually. So the vertical line is called a pipe, but it means or. In fact, maybe I'll label these, right? That one means and, that one means or. The only other one that I think we've shown you is just an exclamation point by itself, which is not. These are all types of logical operators, and you, I think, would have needed these to complete like the leap year problem in the last studio, for example. I mentioned this in the Studio One review video, which is a good thing to remind you of as well, that I do, in fact, publish review videos where I go through the solution for each of the studios. So I know Studio One was pretty easy. A lot of people probably finish it. But if you don't finish the studio in class time, please keep in mind I always record and post these. But one of the things I talked about in the review video was that we can define these logical operators using something called truth tables. So these logical operators take two values, right? What do I see on the left and right-hand side of a logical operator? What type of value do I expect to see on the left and right-hand side of an AND operation, for example? Am I going to see numbers? No? What am I going to see? Blank and blank. Yeah. I'm going to see Booleans again, right? So it's going to be either true or false. And so if we think about, there's only 4 different combinations of true and false that we can have. I can say, true and true. I can say true and false. I can say false and true. Or I can say false and false. This is what's known as the truth table for the AND operation. These are the only 4 combinations of the AND operator that you'll ever see. Right? There's no other way to use it besides this. It is incredibly useful, however, right, to join 2 Boolean expressions together. So I could say 2 is less than 7 and 8 is not equal to 9. Right? I could combine those 2 statements together using an AND statement. So it would need to compare, the relational operators on the left and right first, and then compare the trues and falses that it gets back from those with the AND to tell me what it's ultimately going to get. OR has a very similar truth table, but it's kind of the complementary to AND. So AND requires that both things are true to be true, but the OR only requires one or the other to be true. So the truth table for OR looks a little bit different than this. I believe I covered that one in the studio review video as well. Okay, so let's move on to this next question. Number 3. What does an if statement need to do its job? So first off, let's talk about what an if statement is used for. What am I going to use an if statement for in my code? Why do I use if statements in the first place? When do I make the decision to put an if statement into the code? Yes? So we use them for conditions. I like that word. We're going to use that word a lot, I think. There's another word that starts with a C that I use a lot to describe if statements. We're making a choice. If statements are used to make choices. They're used to make decisions, right? If this thing is true, then I want you to do this other thing. If it's not true, then I don't want you to do this other thing. Or I want you to do something else, right? So if statements allow us to have forks in the road, right? And I get to make a choice. Do I take the left fork? Do I take the right fork? That's how if statements work. If I want to actually put one in my code, if I want to write an if statement in my code, what do I need? Obviously, we need the word if. What comes after the word if? Not brackets, but you're on the right track. Parentheses, I guess you could argue parentheses are a form of brackets, I suppose, but we need parentheses after our if. What goes inside the parentheses? Yeah. The condition. So that's how I would say it in English, right? Condition. But really, what do I mean by a condition? What is a good condition? What is the type of the condition? True or false. So it's a Boolean, right? It's a Boolean. That means anything that evaluates to be true or false can go inside of these parentheses, right? So I could quite literally put the word true inside of there. That's a little silly. I'd say that's pretty rare, pretty uncommon. I think, more like what we're going to see is something like, 2 is less than 7. So that's using one of our relational operators, right? 2 is less than 7. So if this is true, what else do I need after this if statement, after this condition? Now it's your turn to say that thing you said before. Brackets, yeah. Here's where the brackets come in. These are called curly brackets or curly braces. We're going to see them a lot. And inside of here, we can put any code that we want. We'll run this if condition is true. So if 2 is in fact less than 7, which it is, right? Then it will do anything that happens inside of these curly braces. So I can put any lines of code that I want to in here. Could be a print statement, could be a variable assignment statement. Maybe I need to do some math. Maybe, right? Anything that I can think of in code I can put inside of here. If the condition is true, I do this stuff. If this condition is false, I skip it. Right? So if the condition is false, then I just skip it. I just jump over everything that's in these brackets and I don't do it. I just skip that thing. So our choice that we're making right now is, do I do the stuff that's inside of here or do I not do the stuff that's inside of here? That's the choice that we're making. I want to come back up to this condition though and kind of try and give you more accurate ideas of what you're going to see, because this is also another one that I'd say is pretty trivial. I don't need the computer to tell me that 2 is less than 7. I already know that, right? What's going to happen more likely in practice is that I'll have some variables. And so I'll say something like, is x less than y? And, okay, sure, I can see right now that x is less than y, but you could imagine I could change these values and run it again and make it so that this would be false if I wanted to as well. Maybe I don't even know what the values of x and y are. Maybe it doesn't matter to me that x is 2 and y is 7. I just need to know if one is bigger than the other to make my choice. That's our job as a programmer, is to define what conditions matter to us and say that in the code. So that brings us down to our next question. For the example that we just talked about here, I either choose to do what's in the if statement or I skip it. So there's really not it's kind of a fork in the road, but really it's more of just like an optional section of code. But I can actually expand these if statements, right? Maybe there's more than one thing I want to check for, more than one possible outcome, more than one condition that I am concerned with. And so that leads us to this question here. What's the difference between else and else if? Does anybody know the difference between an else statement and an else if statement? Yes?
Else if introduces an additional condition.
Uh-huh.
So it's like another optional form.
That's correct. Else if is used, you said it perfectly actually, the very first thing you said. Else if is used if I want to introduce an additional condition. So if I only have one condition, there's only 2 outcomes, true or false. If I introduce a second condition, right? Now the first condition can be false, but I have another condition that I can now look at and choose that one to be true or false. And we can actually combine as many conditions as we would like using else ifs. So there's no limit to the number of else ifs that we are allowed to use here, right? After every else if, I have to put some sort of Boolean condition. So, I could say if x is less than y here, otherwise if x is, less than 9, right? Then maybe I want to do something else here. So, and then if x or if y is less than 9, then, we'll do something else, right? So the way to interpret an if statement like this, we're going to start at the top and evaluate this condition. If it's true, then I'll do the stuff inside the brackets that's associated with that condition. If it is false, then I look at the next one. I say, all right, this one was false. Is this one true or false? Let's see. So if this one is true, then I'll do the something else. If this one is false, then I skip that and I move back down to this one. I say, all right, is this one true or false? So for every else if that I have, for every condition that I have, I'm asking the question, true or false. As soon as I find one that is true, I'm done. So if the very first one is true, I won't even bother asking these ones down here, right? In other words, it locates the first true condition that it can and does that thing, and then the whole if statement is over after that. The whole if statement is finished. So it finds the first condition that it can and then moves on. Down here at the bottom, we have an option to add else. I think of else, whoops, that's not what I meant to say. I think of else as like it's like a catch-all, right? It's like, if all else fails, do this. That's quite literally what we're getting at here. If this condition is false, and this condition is false, and this condition is false, then I will do this. Notice that there's no condition here, right? The condition here is that everything above is false. So I don't need to say what the condition is explicitly here. If I make it down here, I know all three of these must be false. So I'll do this thing. Contrast that, though, for a second with what I had up here before. If I don't have that else on the end, and all three of these conditions are false, what happens?
Nothing here.
Nothing. Nothing, right? If I don't have an else and all of my conditions are false, then it's not going to do this, it's not going to do this, and it's not going to do this. So it's like, all right, there's three potential options here, but I'm going to skip all three of them because they were all false. If you have an else on the end, you guarantee that you're going to do at least one thing, right? If all three of these things are false, then I'm definitely going to do this no matter what. So, if it's just if, else if, you're going to run the first one that you find is true, but if they're all false, you might not do anything. If you have ifs and else ifs with an else on the end, then you know for a fact you're going to do at least one of these things, right? Based on what the conditions are. So doing zero things is not an option. But notice that we'll never run more than one of these. I always stop after I find the first true condition and do whatever that one is, and then I don't even bother checking the other conditions after that. It always matches the first true condition that it can find and then moves on. It's really up to us, though. Again, I want to reiterate. It's up to us as programmers to make the decision. Do I need an else if here? Do I need an else here? Right? The computer is not going to help me with that. The computer is not going to tell me that I need an additional condition. It's up to me to analyze the problem, figure out, oh, there's actually 4 different ways this could go. Let me write out all the different conditions for those 4 different ways. That's my job as a programmer to do that. That's my responsibility as a programmer to do that. Any questions before we move on to the next topic? Everybody with me so far, I hope? All right, let's talk about loops. what are the different parts of a loop? And actually, this question is a little ambiguous, I suppose, because we introduced two different kinds of loops to this section. But I would argue that, even though there are two different kinds of loops, the parts of the loop are similar. Maybe not always the same, but you're always going to see generally the same parts of a loop. In fact, just to make this a little bit more explicit, why don't we talk about for loops first? For loops, recall, start with the word for, obviously. Hopefully that's obvious. They have parentheses afterwards, just like if statements do. But what I'm asking you are, what are the different parts that I see inside of these parentheses? How many things are inside of here for a for loop? 3 things. Who can give me one of those 3 things that go inside of the parentheses for a for loop? Anybody got one of the 3? So in English, I would describe the first part as initialization. Initialization of a loop variable, something to keep track of where we are in the loop. And maybe I should take a step back and talk a little bit more about what we're actually doing with the loop, especially contrasting that with our if statements. If statements are used to do choice, so picking a path out of multiple options. Loops are used to perform repetition. So loops are used to repeat the same chunk of code over and over and over again. So yeah, I do an initialization. The second part is going to be some sort of condition. Just like we saw with an if statement. It's actually very similar. It's got to be a Boolean, just like we saw for an if statement. And then the last part is going to be the update. So to see, a more concrete example with some actual values, maybe I'll comment this one out and draw and put in a real loop. I might say something like for int I is equal to 0. So that's my initialization. I'm saying I want to create a brand new variable to track this loop called I. I is the variable that I'm using to track this loop. The condition might be I is less than 10. So I'm saying that if I is less than 10, I want to do another repetition. If I is greater than or equal to 10, that's my cue that the loop is over and I want the repetitions to stop. No more repetitions, right? The last statement is called an update. So I might say something like I++. What's the plus plus do? Adds 1. So what that means is that, the first time through the loop, I is going to be 0. The next time through the loop, I'll add 1 to that. So the second trip through the loop, I'll be 1. The third time through the loop, I'll be 2, 3, 4, 5. Notice that with I starting at 0 and counting upwards by 1, this condition is guaranteed to eventually become false, right? Guaranteed to eventually become false. It turns out that's actually really important. You absolutely can get into trouble, for example, if I were to say, I minus minus here instead of plus plus. If I count down by ones, I'm going to start at 0 and count downwards. Well, I will always, always, always be less than 10, right? It's kind of a bad thing. We would say that this loop would run infinitely. It would run literally forever till the end of time or until I tell it to stop. That can happen. In fact, I'll probably show you a more concrete example of that later on. But the point I really want to make clear is that, yeah, you have to write these parts of your loop in such a way to ensure that this loop will eventually stop. We typically do not want things to run forever till the end of time. That doesn't really work for us as humans. So it is our job when we're writing loops to make sure that this condition will eventually be false and that the loop will eventually stop so that we can move on to the next part of the program. Let's contrast this with the second way that we can use to write loops, which is a while loop. I'd like to argue that we can use the same 3 parts if we want to. They're just in a little bit of a different place. So for a while loop, I would actually inside of the parentheses, the only thing that we'll see is the condition So where are the other parts then? Well, the initialization is going to take place before the while loop starts. So I would actually initialize my loop variable first, and then the update takes place within the loop itself. I'm making the argument, I'm making the claim that, this for loop and this while loop are going to repeat the same number of times. Or I could even be stronger than that. I'm going to say they're all going to start from I equals 0 and repeat until I is equal to 10, and then they're going to stop. Right? That is how these two loops are set up to run. Notice all the same parts are there. I see there's I equals 0, I less than 10, I plus plus. It's just two different ways of getting us to the same place. Which kind of brings us to this last question here. I sort of already answered this one, right? What's the difference between a for loop and a while loop? I kind of already answered that one. But this one is definitely worth talking about. When should we choose one over the other? It's very important. The general rule, well, first off, I want to say, in many situations, that's true not just for this class, but just in general, in many situations, it doesn't matter. You can use a for loop, you can use a while loop, they'll both get you to the same place. Doesn't matter. There are many problems for which that is true. So which one should you use in that case? Whichever one feels most comfortable to you, honestly. Whichever one you feel best about using to solve the problem. I'm not going to argue and say, you have to use a for loop here when a while loop could also get the job done. I think either is fine. But there are some situations in which for loops are considered better and other situations in which while loops are considered better. And it all has to do with how many repetitions need to be made. Or more specifically, do we know how many repetitions need to be made? If I know that I need exactly 10 repetitions, or if I know that I need exactly X repetitions, right? Even if I don't know exactly what X is, I just know I need X repetitions. A for loop is considered the best loop for the job. So if you know exactly how many repetitions you need, for loop's considered the best tool. You can use a while loop. Nothing wrong with that. But for loop's generally considered better. If you don't know how many repetitions it's going to take to finish the job, then a while loop is considered better. And so that might lead you to another question. When would you not know the number of repetitions? Well, consider, what if the number of repetitions is based off of some information that somebody typed in? What if I set up the scanner and the first question I ask you is, how many times do you want to run this? And you could tell me a number, right? You could say, I want to run this 8 times. Well, I don't know what that's going to be until you type it in. Or another thing another perhaps better example, one that will show up on your next homework assignment, would be to say, I want the user to type in a positive number. I want them to type in a positive numeric value. But I can't stop them. I can't stop them from typing in negative numbers, right? There's nothing that will physically stop me from typing in negative 10, even though the computer's asking me for a positive value. Well, if I want to, I can force them. I can sit there and I can say, oh, you gave me a negative value. Please type in a positive value. But how many tries? How many tries is it going to take them to give me a positive value? I literally have no way of knowing. If I'm very stubborn, I could sit here and type in negative 10 for the rest of my life. And you would have to sit there and keep asking me to type in a positive value for the rest of my life, right? However many repetitions I decide, until I get a positive value. So in that case, a while loop is definitely the best choice for the job. Anytime the information is based off of somebody else doing something, somebody else behaving and giving you valid values, we have to assume that that person may not play nice with us sometimes. They may not understand. They may not be very smart. I don't know what the case may be, right? But they may give us the wrong value, in which case we need to sit there and repeat over and over and over again until they give us a proper value. So that's a sort of the classic case for when we want to use while loops over for loops. All right. Are there any questions about what we've covered so far? Yes?
How do you print a loop?
How do you print a loop? So, I mean, I can put any statements I want to inside of loops. So if I want to include a print statement inside of a loop, I can. In fact, this is definitely one of the exercises, I think. One of the exercises asks you to take a loop very similar to this. Let me comment out the rest of my work so that it's not getting in the way. I think that'll be okay. Yeah, perfect. In fact, I would like to take a moment and talk about this loop maybe in a little bit more detail, right? Using our good friend, the debugger. I love using the debugger. You're going to see me use the debugger almost every class to show you how code works in more detail. So let's set a breakpoint on line 44 here. That means that when I run this in debug mode, which I'm about to do, it'll pause on this line. So I'll click the little bug up here. Yes, I do want to switch. Notice in my variables window, I have X and Y because I created X and Y up here. There's nothing for I yet though, right? I has not been created yet. I haven't gotten that far. But if we step through this using the step over arrow up here, you'll see that as soon as I step into the loop, I is now 0. This statement says, all right, print out the value of I, which it happily does. There's the 0. It's at the end of the loop, so it's about to do the update. You can see I is still 0, but the next time I click the step button, we'll see I go up to 1. And it, even though we didn't see it, it also did the comparison. It said, is 1 less than 10? Yes, 1 is less than 10. So I need to go into this loop again. And I'll print out I, which is now 1, right? And then I goes up to 2, and I print out the 2. And then I goes up to 3, and I print out the 3. And so on and so forth until we get to the very end of the loop. All right, I is now 9. I print out the 9. So I is now 9. I'm about to increase it by 1. That'll make it 10. Is 10 less than 10? No, that's false. 10 is not less than 10. So when I step now, it has exited the loop. It said, oh, the condition was false. The loop is over. I'm going to move on to the next thing. Any other questions I can address based on what we've talked about so far? Are there any... Oh, yeah, sorry.
I have a question.
Yeah.
You didn't have to put I in the print section.
That's correct.
For it to print
Sure.
it?
Yeah.
Why is that?
I mean, it's just going to print out nothing. So what'll happen when I run this, it's actually doing the same thing. It's repeating and printing out nothing. In fact, you could even count the nothings here if you wanted to. Yeah, or, I mean, I don't have to print out the number. I could print out the same word over and over again if I wanted to, and it will happily do that, right?
Okay, so when it was in the debugger earlier, it wasn't actually, and it was telling you I, it wasn't printing out I, it was just telling you, the coder, what I was.
That's correct. There's a difference between what gets printed and a difference and what I actually see in the debugger. That's right, yes. In fact, I mean, I can show you using the debugger now that even though I'm no longer printing the value of I, it still very much exists. There it is, I is equal to 0, and follows the same thing. Even though I changed the code to do something different, the loop is still operating the same way in terms of starting I at 0, counting up by 1, and ending at 10. I just said I wanted to do something different in here this time. Yeah. And I think that's an important point. A lot of these examples are very simple, but any code can go here. Anything. Literally anything. So that could be a variable assignment. That could be doing some math. That could be an if statement. That could be another loop. In fact, I will hopefully see an example of that later on today. I'm hoping we have time to get to an exercise where we see a loop within a loop, because that's another very common thing that we might expect to see. Did you have another question, or?
Yeah, really quick. When you commented out earlier the code that you didn't want to bother with, you did like all of it very quickly.
Oh, yeah. That's me using a hotkey. So I thank you for asking me to stop and explain. I know there's a lot of stuff that I just kind of breeze through and don't even realize. So yes, I use command slash. So if you highlight a chunk and hit control slash, might be different on a Mac. I use a Windows machine, so I'm not as familiar with Macs. But on my Windows machine, control slash allows me to comment out big chunks of code in one go. It's a very useful thing to know how to do, yeah. Any other questions before we move on to the next thing on our agenda? Okay. So the next thing that I like to do at this point, now that we've kind of got a basic overview of today's topics, I would like to give you all the opportunity, if you would like, to ask me to go through any of the exercises from Module 2. So I, of course, have those all loaded up here. I asked you to take a look at these before class. If there are any you got stuck on, if there are any that you were confused about and you want to see me go through a solution, now would be the time. Happy to do it. Is there any that anybody would like to see me walk through up here? Yes?
This isn't exactly how it was supposed to go, but the first one in Module 2, like the very first one,
Yeah.
I was attempting to have it where you could input whether it was raining or not.
Okay.
Instead of having it
Sure.
just instead of just having it.
Yeah, just having it coded here.
Yeah.
I think that would be doable. I don't know that I've shown you how to do that yet, but I think it would be doable. We'd have to make the scanner, which, if you need to review past exercises on how to do that or copy paste it in, that's totally okay. You also would have to import the scanner, so that can be done for you automatically. Usually I just let Eclipse do that for me by clicking on this line that says import scanner. Or again, if you need to copy this line from another file that we've already done before to make it work properly, that's okay too. Here, I would think that we would need to swap this out to say in.next boolean, since I'm specifically looking for a boolean. And then, I need to enter a prompt here as well. So I'd probably say something like, is it raining? But I'd have to say, the only values I would accept would be true or false, right? Not yes or no, but true or false. Because it's specifically looking for a boolean. I believe this would do the trick, but I can try it out and test it real quick to make sure once I fix that. Is it raining? False. Drive carefully. Yeah. Seems like it worked. Can run it again and say true and see if that does what we would expect. Yeah. Awesome. So yeah, using the next boolean there, I think, is the trick. We haven't used that before, but there's no reason not to. If you want to.
To convert with the if, using if and else, make a string into a boolean if you wanted it to be yes or no. I would see how it could maybe be helpful for it to be more conversational. Like, is it raining? And then I would say yeah, and then have it translate that into a boolean.
Yeah, so you actually could, if you wanted them to type in yes or no. That's a great question, because that's not how people are used to talking, right? If you wanted to, you definitely could. So we would need to change that to be a string, and this would be in.next. And then here we would need to do a comparison. Is raining? Now, this is where things get a little bit confusing. Some people would probably try and do it like this. If it's equal to yes. Unfortunately, strings are a little bit different than the other things that we've talked about, and the way to compare strings is not with double equals, it's with dot equals. And if you're confused right now, don't worry about it. This is not on today's agenda at all. This is just above and beyond what we talked about. We'll talk about this a little bit more towards the end of the semester. But since you asked, yeah, you could do something like this. Absolutely. Question?
Yeah, could you please go over 2.07? Like find and replace one?
The find and replace one? Sure. Absolutely. So this is dealing with a string here. And you can see that instead of the letter L, they've replaced the letter L with the number 1 in this string. And we want to fix that. We want to write code that will go through this and replace all of the number 1s with the letter L that exists. And so, we don't know how many 1s there might be. I can look at this and say, yeah, there's 2 in this particular example, but it would be very easy for us to change this to say something else, and then there might be 10 numeral 1s in there, or 100 numeral 1s in there. And we want our code to work for whatever situation we happen to run into. So I think that's why a while loop is a good choice here, right? I don't know exactly how many number 1s are going to show up inside of this message. I want to keep replacing them while there are still more number 1s in this message. And so we start off by using this index of function, which is kind of a sneak preview to what we're going to be talking about next week. It's basically asking us, where does the number 1 appear? So it's literally counting from the start of the string and saying that this is in position number 7 or 8. I'm not sure. It doesn't actually matter what the actual position is, right? What's important to know here is that if there are no 1s in here at all, if it doesn't show up at all, it tells me -1. So -1 is the result that I get when this value doesn't show up. So if it's greater than or equal to 0, that means that there is a 1 inside of here. This will actually tell me the exact position where it appears. So, counting from the beginning of the string, it'll tell me the exact position. That's what this line is going to do. And then this is going to do some clever use of the substring message to replace that number 1. Basically, what it's doing is grabbing everything in front of that letter, storing it in a variable called first part. It's grabbing everything after that letter, storing it in a variable called last part. And then it's using concatenation. Notice that this is not the number 1, it's the letter L. So it's actually replacing that letter L it's replacing that number 1 with the letter L. But listening to me talk about it, I think is honestly not nearly as good as watching it for yourself. I would encourage you, especially for this one, you're not actually asked to write any code. Well, I guess you are a little bit. But mostly you're just asked to understand what's going on. Run it through the debugger. I'm going to set a breakpoint right here on line number 13 and click on the little bug and start walking through this code. So here I am, right? At the very beginning, nothing's happened yet. Just getting started. As soon as I step in, there we go. It tells me, all right, it found a 1 at index number 7. So at the 7th letter of that string, it found that number 1. I can see that it's remembering that position 7. This line is saying, give me everything from the beginning of the string up until where you found that letter. So if I look at the first part, I can see it says have a, and so it gave me everything up to, but not including that number 1. This line is going to give me everything from that position to the end of the string, so everything afterwards. So you can see that, all right, I've got the first part here, I've got the second part here, the 1 is gone, so this line we're just going to do some concatenation. Stick them all together with an L in between, and now we can see there's the message, there's the updated message. I know it's a little hard, oh yeah, that's easier to see. That 1 has now been replaced with the L, but this one down here is not. I haven't gotten that far yet. So it tells me, yeah, it replaced it, but we're not done yet. There's still more 1s in there. So I'm going to grab the next one. It happens at position 22. And we'll do the same thing. Give me everything that occurs before position 22. That's, have a long and happy. Give me everything that that takes place after 22. It's just those last few letters. Replace that 1 with an L. And now we see that's successfully been replaced. If we want to do the exercise that it's actually asking us to, it just wants us to modify and add a counter that counts the number of ones that have been replaced. So I think that's worth discussing as well. I'm going to make a new variable called counter. I'll start it at 0. Every time I go through this loop, I know I've done one more replacement. So inside of this loop, I'll just say counter plus plus. And then down here, I can just say something like replaced counter letters. And with that simple modification, we now have a message at the end that tells us exactly how many letters got replaced. And we can see that matches with the other messages that get printed out. I'm not surprised that you asked me to go through this example. This is, I think, one of the more complicated ones. However, it's complicated not necessarily because of the looping, but more because of some of the string functions that you've been asked to use. So hopefully that answered your question. Yeah?
Quick follow-up. Why is index plus 1? And how does that relate to the rest of the line?
Okay. For that, we just have to look at the documentation. Begins with the character at the specified index and extends to the end of this string. That's just exactly what it says. I didn't write this, right? I didn't write this code. I am just doing what it tells me. I'm using it based on what it tells me. That's programming. Programming is a lot about, what is this thing? Let me go read about it. Oh, that's what that thing is. That's how I can use it. I know that it does it that way because that's what was told to me. And you have to take that. You have to trust that information. Question?
So when you do substring here from 0 to index, it's working from including like whatever letter starts at 0.
Yep.
Up until but not including index. And then the next one starts the one after index.
Correct.
Okay.
Yeah. I mean, there's two different forms, right? This one I'm giving it two numbers, a start and a stop. This one I'm giving it just one number, only a start. If I only give it one number, it just assumes that I stop at the end.
Okay.
Yes, in the back. Perhaps. For reversing a string? Okay. I mean, again, this one is just asking you to. All I can really see to do on this one is go through the debugger. I guess I'm not opposed to doing this one, but again, if the question is about this stuff, I would say not worth it. I'm more interested in talking to you about fors and whiles than substring today. I'm not necessarily surprised that you're asking me about substring, but I really don't care about this that much today. I care about for. I care about while. I care about if. So, I'm happy to show you that when you run this through the debugger, you start with a word and a blank word, and then it's going to grab the last letter one at a time and start tacking it on to the reversal. You can see it's grabbing, actually it did it the other way. It grabbed the first letter and tacked it on one line at a time. But I would much rather look at some simpler exercises, if I'm being honest with you, that focus on, again, the basics of how to use these loops and less on the string stuff. Sorry to kind of dodge that one, but yeah, does anybody have any other ones? Yeah.
Does a space count as an index?
Spaces absolutely count, yes. Spaces absolutely count. I brought some exercises to work through as well, so maybe we'll switch over and do one of those. Starting with, whoops, that's not it. Let's do this one. Let's do the Fibonacci one first. I know I skipped number 2. If we have time, maybe we'll go back to it, but I am a little conscious of the fact that we only have a few minutes left, and I do want to get through at least a couple of these today, if I can. So this one is starting off with it's explaining the Fibonacci sequence. I am assuming maybe you've seen this before, but if you haven't, here's how it works. The first two terms are defined as 0 and 1, so those are just given to you, right? The first term is 0, the second term is 1. The third term is computed by adding the previous two together. So 0 plus 1 gives me 1. 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. So on and so forth, right? Your task is to write a program that prints out the first 50 numbers that appear in this sequence. I'm going to give you a few minutes to work on this. Take a few moments, talk to your neighbors. I'll be around if you get stuck, if you need any help, and then we'll go through this solution together, like I said, in 5 or 10 minutes or so. Okay, so this means you tried to set it up and work towards losing, but it doesn't want to delete it. So it's urgent to try. So you just have to type new. It's very common. Okay, I know some of you are still working on this, and that's fine, but I do want to keep things moving because we only have about 15 minutes left, and I definitely want to show you the solution to this problem before we take off. So let's talk about it. The first thing, I think one of the hardest things to do with any of these problems is to identify what tools in our toolbox we need to solve the problem. So I think a lot of people understand what this sequence is, but how do I take the stuff that we've learned? How do I take? I'm showing you how to use tools, right? I'm showing you how to use if statements. I'm showing you how to use loops. I'm showing you how to use variables and other kinds of things. How do we take those tools and apply them, right? It's like I can show someone how to use a hammer, and I'm like, okay, go build a house. And it's like, well, how do I actually use that hammer and apply it to build the house? There's a lot that happens in between, right? So let's talk about that. Let's talk about how we can identify what we need to include in our code. Starting with these first two values here, I told you that they don't need to be computed. They just are, right? They're given to us. These first two values are given to us. They are constant. They are just defined that way. And so you could start out by just simply printing them out, because that's what we're trying to do, right? I'm trying to print out the first 50 values of the Fibonacci sequence. And I think this isn't actually a terrible way to start. I think, I don't need to do any math to get those values. I just need to say, here are the first two, right? But if I want to go to this one, or really beyond, that's when things start to get a little bit more complicated. I need to know, in order to compute this value, for example, I need to know what this number and this number are in order to compute this one. So that's two pieces of data that I need, and that immediately tells me that I need two variables. I got to have two variables to track those pieces of information. So, okay, I'm going to call those previous term. So the term that's immediately previous, right, would be 1, and then previous term. Maybe I could have said that in a little bit of a more concise way. I don't know. Hopefully you get what I'm going for, though, right? The previous term is this guy, and the previous term is this guy. And so then to get this number back out, all we have to do is we have to add those together. So I could, say system.out.println previous term plus previous term. And that's great. That'll definitely do the trick. That'll definitely get us the next term in the series. But hold on a second. I now need to do the next term in the series. So here's where the repetition comes in, right? Instead of could I sit here and type this out all in all 50 terms all the time? Yes, but oh my gosh, that sounds terrible. It sounds awful. I want to use loops. I want to use loops to help me out with this. And our first thing to decide is what loop do we want to use? We've got a choice. I actually think this is a situation in which either loop could work. I saw some people using while loops. I saw some people using for loops. I actually think this works very well with a for loop because I know exactly how many times I want this to run. So let's say that for I is equal to 0. How many times do I want this loop to run? Somebody help me out with that? 48, because I already did the first two, right? So, all right, for I is equal to 0, I is less than 48. It might seem like this is a little silly way of saying what I'm trying to say here, right? But notice that if I start at 0, it will be this will run 48 times, right? If I count up by 1, because once it is equal to 48, it will stop. You might be wondering why I'm starting from 0. That will become a lot more clear with our next topic of arrays, which we're going to talk about next week. Okay, so really then, I want this print statement to be inside of here, right? And that moves us a step closer to what we're looking for. In fact, if I run this right now, you can see we will have made some progress towards our goal, except, okay, the first two numbers are, actually the first three numbers are right, but then, whoops, it just says 1 for everything after that. So, okay, not quite correct. Consider that after I compute this guy and print it out, my previous term is no longer this, right? My previous term is now this. In other words, I'm getting ready to compute the next value. So I need to make sure that previous term points here, and previous term points here. And when I get ready to do this value, I need to make sure that previous term points here and previous term points here. So I have to update what my previous terms are every step through the loop. Does that make sense? So let me come back down here, and instead I'll say int next term is equal to this. Right? That's what the next term is, and I can just print that out directly. Once I have completed that, I need to update my previous terms. So my previous term is now going to be the next term. Actually, I think I might have done that a little backwards, huh? Let me think about this. Well, I'm going to make the mistake and see if we can't fix it. Here we go. The previous term is just going to be just equal to my previous term. I think I made a mistake here, but let's run it and see what happens. And then maybe I'll use the debugger to walk through and show you why I think, oh, we actually kind of did get it though. Well, it's not correct though. 1, 1, 2, 4, 8, 6, what? That's not right. That's a different series, right? I made a mistake. But let's walk this through the debugger and try and explain to you what the mistake is and how it actually is supposed to work. Not that one. Here we go. I set my breakpoint on line 20. You can see that the previous term is 0. The previous term is 1. I'm going to add those together to compute my next term, which is 1. And then I try to update my previous terms. I say previous term is equal to the next term. So what I'm saying is that, this is now my previous term. And I think that part may actually work. But when I say my previous term is equal to the previous term, well, I just changed this value. Do you see that? I just changed this value. So it's not going to get updated properly. Actually, in this case, it happens to be, it's accidentally correct, right? But if I go a few more times through, you'll start to see what the problem is. I've computed the 2, and I've successfully printed it out. So now I'm getting ready to do this, which means double previous should be 1, and the previous term should be 2. But by updating these, you'll see that, all right, the previous term gets made to be 2, and the previous term also gets made to be 2. No, that's supposed to be a 1. That's supposed to be a 1. It's all about the order of operations. Consider that I change this one, and then I use it here. I think a simple switch of the order of these statements will actually fix that issue. So let's run this through the debugger one more time. A few rounds, and see. There's the 0, 1, 1. Here comes my 2. The previous term gets updated to be a 1. Now the previous term is a 2. So when I add 1 plus 2, I get my next term of 3. The previous term is going to be a 2 now. And the previous term is going to be the one that I just printed out, which is a 3. I add them together. I get the next term. This is going to do it. And if I allow the program to just run to completion, whoops, we'll see that, all right, this is the Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8, 13. That's correct. That is the Fibonacci sequence. However, when you get down here, you'll notice, things go off the rails. How did it get negative? That's a little secret that we haven't talked about. There's actually a maximum value that can be represented by integers. The largest value that I can represent is 2 billion something. I don't know what the something is. You can Google it if you really want to know what the actual value is. But once you try to go above 2 billion something, you can't. It actually wraps around and goes negative. That's called an overflow. That's a very common thing that we see in computer science called an overflow. Are there any questions about this problem? Any questions? Yes?
Are there any methods that we can solve the overflow so that it still shows the number?
Can we solve the overflow? Yes, you can actually. So how do we stop something like this from happening? There's actually another data type that you can use if you want to that's very similar to an int. It's called a long. So a long is just a bigger int. I don't remember what the maximum for a long is. It's bigger than 2 billion. I don't remember what the... So yeah, you can see here that I solved that problem, but I haven't actually solved it. I've just kind of kicked the can down the road, right? Because eventually I'm going to hit the maximum for this one, and it's going to do the same thing. And then the question is, well, how do we solve that problem? There's a solution to that one as well. Unfortunately, the permanent solution, or the good solution, requires techniques that we aren't going to see until later this semester. So I don't have a good answer for you right now that won't hurt your brain, but later on this semester, yeah, we'll definitely see some techniques. It definitely is possible, and if you've ever played, idle games where the numbers get giant, you know that for a fact. Or just the idea that we like to send rockets to space and stuff that require really big numbers. We definitely can do it. Just have to be careful. Yeah. Any other questions? We didn't get to nearly as many of these exercises as I would have liked, and that's okay. I really don't mind. I mean, the session is really for you all, but I want to reiterate, please look at the stuff before you come to class. I think, there's no substitution for that. And if you want to look at the rest of these exercises as some extra practice, I'd be happy to go over them with you in my office, talk to the TAs about them. Otherwise, I'll see you in the labs for Studio 2 on Wednesday. Have a good week.